Hey everybody, Mr. Gibson here. So this activity, we're going to start to explore how to write or draw orbital notations for different elements. So it is super important you watch the rest of this video or else you may be a little confused. So the first thing we're going to do is we're going to open the interactive periodic table right here. Just have it open already over here. And this has a bunch of cool stuff. It shows you properties, electrons, isotopes, compounds. I would recommend you stay on electrons for today. And here we have all of the elements, and it actually will show you which elements that their electrons fall in the S, P, D, and F sublevels. And it will show you, if you hover over any element, it will show you its orbital notation right here. So this is a good way to check to see if you are doing this correctly, okay? Because this is not super easy stuff. I want to make sure you guys have a safety net. So this periodic table is your safety net, okay? So let's go back here. It says, then open the attached PDF, read the introduction about orbital notation, follow the directions, and using the periodic table, answer the questions regarding orbital notation. All right, here's what I'm going to do. I'm going to open this up, and I'm actually going to solve two problems with you in this video to show you what to do. So here it is. You're going to want to read this, and basically it shows you that each sublevel, S, P, D, and F, has a certain number of orbitals. So S has one orbital, P has 3, D has 5, F has 7. And we represent each orbital by drawing a box, okay? And there are certain rules for how you fill up the boxes. All right, so for example, the arrows in the boxes represent the electrons, and they must, if you have you can have 2 electrons in every orbital, and they must be spinning or pointing the opposite direction. So here in each box, you see that you have electrons going up and down. Okay, that just shows that they're spinning opposite directions, and only 2 can fit in each box or each orbital. Okay, so this really has just 3 parts to it. The first part says, write the name and symbol for the elements with the following orbital diagram. So here it gives you the orbital notation, and you have to tell me what element that is. And then down here it says, write the orbital diagrams for the following. You may abbreviate using a noble gas. So here's what we're going to do. So for number 1, let's just do this together. So here we have the orbital notation. It shows you what energy level they're in, what sublevel the electrons are in, and then we have a box drawn for each orbital in that sublevel. Now, here's the easiest way to do this. The arrows are the number of electrons. The atomic number tells you the number of protons, but also tells you the number of electrons. So let's just count the number of electrons, the number of arrows, and match that to an element on the periodic table. So this one has 1, 2 arrows, 3, 4, 6, 8, 10, 12, 14, 16, 18, 20. So this element, whatever it is, will have 20 electrons. Well, let's go over here. And what element has 20 electrons? Well, calcium does. And you can also double check this way. See, so calcium, I hovered over it, so its orbital notation is now up here. So we've got these boxes filled in with arrows, which also match this here. See how it ends on 4s? And this also ends on 4s. Okay, so this element is, let's get our text box out. This element is, I'm going to lower my font 3 to 10. That's a little small. Let's go up to 12. And I'm going to do blue. This is calcium. Okay. All right, now you see this here. What in the world does that mean? So here you've got this symbol for krypton, and you've got an orbital notation. So all you would do here is take the number of electrons here and then add it to the number of electrons that krypton has, which is 36. So you take 2, 4, 6, 8, 10, 12, 14, 16, 18, plus 36. Do that math. I believe that is 54. So you're going to go over here, find 54, and that is xenon. So that one would be xenon. I told you I was going to do a couple. I'm actually going to do more than a couple with you, okay? There's that. That's how you do each one of those. Now down here, number 7 says there is an error with each of the following orbital diagrams. So you're going to try to explain that error using what it told you up here. So remember, electrons have to point opposite directions within the same box. If you're going from left to right for a sub-level, you would fill up the up arrows first in each orbital and then go back and fill in the down arrows. Okay, you would not move on to another orbital, or excuse me, another sub-level or energy level until all of the boxes for that one are full. So for example, you've got 1s2, 2s2, and then 2p here. You wouldn't go on to 2p if that 2s hadn't filled up with electrons. Okay, it's just like filling water up in a cup. Okay. Now let's go down here to the somewhat difficult part. This says write orbital diagrams for the following. You may abbreviate using a noble gas. So you can do this if you want to, but I'm not sure that we're quite at that level. So here's what we're going to do. I'm going to do one of these for you. So you have the element. So first thing you need to do is go over to the periodic table and figure out how many electrons that element has. I am actually going to do, let's do carbon. Okay, here, number 15. So let's go over here and find carbon. Carbon has 6 electrons. Okay. Now, if you want to double check yourself, it just showed me the correct orbital notation. But I want to go back over here and draw it. So there's really not room here to do this, so I gave you an extra page down here. So let's go down here, and you'll go in order, but I'm starting with carbon. So I'm going to do number 15. This is carbon. And it has 6 electrons. I want to make sure to note that. Okay. I'm just going to space over. And what we're going to do is you're going to take your shapes. Let's just use a rectangle. And these are going to be our orbitals. Okay. So we know we're going to, whoa, that's weird. Let's not use red. Let's use white. That's pretty weird too. Okay, I fixed what was going on. You're going to want to make sure that your stroke thickness is really small. So we're going to draw our boxes. So there's one box, okay? And that is going to be, where do we start? We start with 1s, okay? So let's go to the text box. Where's that? Where's the text box? Here it is. And let's add in another text box, and this is going to be 1s. And if you're not sure what goes in what order, go over here and look. Look, 1s, 2s, 2p, 3s, 3p, okay? So just follow that order. This is why watching this video is really going to help you. Now, we've got our orbital drawn for 1s. S only has one orbital. So now we're going to take our drawing tool. And I don't want it to be that thick. We're going to draw our arrows. Carbon has 6 electrons. So I'm going to draw 1 electron here. 1 electron here. So we've got an electron going up and an electron going down. Now, I've only used 2. I'm not all the way out of electrons yet. So now I've got to go to the next energy level. So I'm going to go to 2s. Okay. And s, remember, only has 1 orbital. You can double check that up here. 1 orbital. So I'm just going to draw 1 box. Okay. And this is going to have 2 arrows in it as well to represent the 2 electrons. So here we go. Arrow 1 and arrow 2. Okay. And they don't have to be very pretty, just like mine are not. So now we've got 2, 4. We need 6 total though. So now we have to go to, well, what's next after 2s? It shows here 2p is after 2s. Okay. So I'm going to go back and do 2p. Now, how many orbitals does P have? It doesn't have one. It actually, if you go back here and look, it has 3. So I'm going to draw 3 boxes. 1, 2, 3. Okay. So carbon has 6 total electrons. We've got 1, 2, 3, 4. So I just need to draw 2 more. So let's get our drawing tool. I'm going to draw my electron. Now, here's the thing. My next electron does not go right there. Okay? It goes right here. Remember, you cannot add the second electron until all of the boxes in that sublevel, so P in this example, have at least 1 electron in them already. So I'd have to have a third one here before I would go back and fill this in. Just think of it like sitting on a bus. No one's going to want to sit next to each other until they have to, until there's already 1 person in each seat. Okay, you're not going to have some dude come up and sit next to a stranger when there's an open seat over here. Electrons are the same way. So let's count and see if I've done this correctly. Carbon has 6 electrons, and I've drawn 1, 2, 3, 4, 5, 6 electrons. Okay, now I'm going to go in and probably cut some of these out because that took me a little while, and I don't want this to take you like forever. Okay, so but that's an example of how to do one. If you need any more help, feel free to email me. Good luck, guys.